So let's do one more column design with pure axial load. This is a 9-foot 6-inch or 9.5-foot tall column. In fact, it's a post. What we're actually going to do here. So it's 14 kips axial load, and that's deadless snow, so that you know what to do for the load duration factors. So design this post. So the easiest thing to do is just go ahead and set up and try something. So let's try, generally the posts are square. So let's try a 6x6. I'll be able to see, if these are fairly short problems, I'll be able to see fairly quickly if I'm on the right track here with a 6x6. If I look at the area of that, it's 5.5 inches squared, 30.25. So what's the stress from the load? It's P over A equals 14,000 pounds over our 30.25 inches squared. And we get 462.8 psi. Now on the other side of the equation, my F sub C prime equals the value we look up, F sub C, and then each of the factors here that you're go take a look at. Essentially, all these go to 1, except for this guy is 1.15 due to the snow load. These guys are 1, and then we need to calculate this one. F sub C, we look it up for post and timbers, northern pine. Didn't tell you what it is. Northern pine number 1 is what we're going to use here. Just to mix it up. All right, so if I go look up post and timber, northern pine number 1 for my 6x6, I will get 800 psi. That's table 4D. And now I need to calculate C sub P. And C sub P is that fairly long equation. Before I do that, let's just check the L over D, L effective over D squared. L effective for this one is the full length. We're just assuming this is, conservatively, we can assume the pin-pin condition for this one. It's all axial load. So oops, L over D, not D squared. L over D is my 9.5 feet times 12 inches per foot. And D is 5.5 inches. And I get an L over D of 20.73 inches. 20.73. And so that's less than 50. So this guy's okay as far as slenderness. So let's go ahead and proceed and find C sub P. All right, so this is related to stability. So it's got 1 plus F sub C E over F C star 2C minus the quantity of basically that same term squared, 1 plus F sub CE over FC star over 2C, so that same term squared minus FCE over FC star over C. So I'm not going to write this out over and over. You get the idea. F sub CE, I did this for the other problem as well, 0.822 E prime min over L over D squared, right? If I look this E min up for a post and timber and consider the factors, so I get E prime min equals 470,000 psi. Oops, no, sorry, wrong one. I get 1.3 million psi, and each of the factors on that are actually ones. So that's what I get is 1.3 million. Now I can solve for f sub CE, and I get 9, oops, wait. Sorry, I did this wrong. It was 470. Sorry, don't work with me when you're in 10. So 470 is correct. And then we had a couple factors in here. CMTI, all ones. And so then I come in here with 470. So 0.822, 470,000 PSI. And then our L over D we found already, so 20.73, and that's squared. And I get F sub CE of 902 PSI. All right. Just to make my life a little simpler, well, first let's get the F sub C star going on here. F sub C star. So remember that's F sub C basically with everything except for C sub P, which is what we're trying to find. Okay, so it's F sub C, CD, CM, CT, CF, CI. These guys are all 1. This is 1.5 again. And I get 800 times 1.15 equals 920 PSI. So if I do F sub CE over F sub C star, that ratio is 0.98, since I have to use that ratio over and over here. Excuse me. So let's go ahead and add those guys up. And do I have everything? I do. C, yep, okay. And C for saw and lumber is 0.8. All right, so we have everything to go into that CP equation, so I'm not going to torture you and write all that out because you have all the numbers at this point. So if I put all that into the equation, I get, depending on how many decimals you keep in your calculator, I got 0.681. And I now can get F prime C. So from the previous page, right? Now I'm going to get this value. So all I was missing was I've got 800 times 1.15 times my calculated CP value, which was 0.68. So we lost a decent amount of capacity there. We're only at 68% of that capacity because of the stability item. And this is, so we're used to these factors not being too big a weight on here, but because this is column buckling, they do play a decent size role. So we should get 631 PSI. And that is, I'm sorry, I get like 626 here actually. I had to redo this problem, so it's got slightly different. So PSI, and over here we had a P over A of 462.8. And so that is greater than 462.8. And therefore it's okay. All right. So not too terribly exciting here, but if we look at that in bending, we can use a 6x6. Okay. That was just another quick version of the examples, and you saw we did a similar example, axial load, and solved for different parts on that last one, right? Same idea. This time we tried out a section size. Okay, I could try out a smaller section and see if it works, but it's not terribly over-designed given all the factors with wood. So it's okay to use a 6x6. If you put this in your Excel sheet, you could refine it pretty quickly to find out what makes the most sense. All right.